Hi everyone. Today we're going to study confidence intervals for the mean when population standard deviation is known. Let us define confidence interval. In the case of a sample taken from a normal population with known population standard deviation sigma, we can say with 100 times 1 minus alpha % confidence interval for the true mean mu is, this is the interval. The lower limit is x bar minus z sub alpha over 2 multiplied by this fraction, and the numerator is sigma over the square root of n. And the upper limit is x bar plus z sub alpha over 2. This value is multiplied by the fraction whose numerator is sigma over the denominator square root of n. The x bar is the sample mean. This z is the z value from the normal distribution table. Alpha is the level of significance. The sigma is the population standard deviation. The n is the number of samples. We take note that this value here and this are equal. And this value is what we call margin of error, or sometimes called maximum error of the estimate. We use capital E to denote margin of error, and this value is copied here. Let us have this example. In order to ensure efficient usage of a server, it is necessary to estimate the mean number of concurrent users. According to records, the sample mean and sample standard deviation of number of concurrent users at 100 randomly selected times is 37.7 and 9.2 respectively. Letter A, construct a 90% confidence interval for the mean number of concurrent users. Letter B, what is the margin of error? For our solution, let us copy the formula for the confidence interval, and it's now here. Then, let us list the given of the problem, starting with x bar, and that is 37.7. Next is the sample standard deviation, that is S, and it is equal to 9.2. The n is the 100. Alpha is equal to 100% minus the confidence level. From problem A, we see here that this is 90%. So 100% minus 90% is 10%. Expressing this as decimal, we write 0.10. Now, for the z sub alpha over 2, we write here z sub 0.10 over 2. So we have z sub 0.05. Since our n here is large, so we will take the value of z from the normal curve table. And the value is 1.645. Also, we can see here that the given is a sample standard deviation. We can use the sample standard deviation to estimate the population standard deviation. So we can modify our formula here in the confidence interval, changing sigma into S. Now, we can start solving letter B, the margin of error, denoted by E. This value here is the margin of error, so we copy it here. Substituting the corresponding values, we have now the z sub alpha over 2 is now 1.645 times the fraction, and the s becomes 9.2 over the square root of n is square root of 100. We can simplify the square root of 100 into 10. Using our calculator, the margin of error is equal to 1.5. So this answer we can write under problem B. Here we go. And then, let us now solve for problem A. Using the value of the margin of error in here, let us do the substitution. So it becomes x bar is the 37.7, and the whole value here is the margin of error, so we write here 1.5. So 37.7 minus 1.5, that is the lower limit, comma, and the upper limit is x bar, now becomes 37.7 plus 1.5. Simplifying further, we have now the exact value for the lower limit to be 36.2, and the upper limit is 39.2. This is the confidence interval, and this is the answer for problem A. So we are able to write our answers for this example A and B. Confidence interval for the mean when population standard deviation is unknown. Let us define confidence interval. Most of the time, the value of population standard deviation sigma is not known, so it must be estimated by using S, namely the standard deviation of the sample. When S is used, especially when the sample size n is small, the values are taken from the student t distribution, most often called as t distribution. The confidence interval is computed using this formula. The lower limit is this value, which is x bar minus t with subscript alpha over 2, and this value is multiplied by the fraction whose numerator is s over the square root of n. The upper limit is similar to this value, except this is minus, while this is plus. Let us see this example. Suppose we would like to estimate the mean amount of money, that is mu, which is population mean, spent on books by computer science students in a semester. We have the following data from 10 randomly selected computer science students. X bar, this is the sample mean, equals $249. And S, the standard deviation of the sample, equals $30. Assume that the amount spent on books by CS students is normally distributed. Compute a 95% confidence interval for the mean mu. Let us write the given starting from the X bar, and that is the $249, followed by the S, the sample standard deviation, which is $30. The number of sample n is 10. And then let us write our formula for the confidence interval. From this formula, let us define the alpha, and that is the level of significance. The formula for level of significance is given as 100% minus confidence level. In our problem here, the confidence level is 95%. So we copy it here. And the difference will be 5%. Let us express this 5% into decimal, so we have 0.05. Now, we need the value of t with a subscript alpha over 2. We computed the alpha to be 0.05, and we substitute that value here. Simplifying the fraction, we have now 0.025. This is the subscript of t. Let us take the value of this t from the table, so the value is 2.262. Now, we are ready to substitute the corresponding values in our formula. Here it is. We have now the X bar to be 249 minus the t value sub alpha over 2 is now 2.262. In the fraction, the S is 30. And in the denominator, it is square root of n, so it becomes square root of 10. Simplifying this value here, we will get 21.5 respectively. So for the lower limit, we will get the difference, while in the upper limit, we will get the sum. So the confidence interval is 227.5 up to 270.5. This is the confidence interval for 95%. Take note that the margin of error denoted by E is this value. So you write it here. And a while ago, we were able to solve this, and the value is this 21.5. This is the margin of error. I hope you learned something from this video. See you again next time.